Hi there, this is your favorite math learning channel, and I have a pretty cool number theory problem for you. So we have an equation and we are asked to find integer solutions. Well, of course it makes sense to find integer solutions because I can just pick any x and y and I will be able to find z by just dividing it by 3 and just square rooting it. So it makes sense to just find for integer solutions. And so I want to use different letters. So we will assume that x, y, and z, like pair, satisfies this equation. Okay. So, well, I want to make this equation a bit simplified. So how can I do is that I have the constants of 1, 10, and 3. So let's observe this equation modulo 10 so that I won't get this term. Well, if I do that, I will get that x squared. So this is just going to be 0 because anything multiplied by 10 is just 0 modulo 10. So this is going to be congruent to 3z squared modulo 10. Well, that's cool. Now it looks simpler. And let's see now how we can achieve this. Well, I will write the values of x and x squared. So if I put values of x, well, x can be 0, plus minus 1, plus minus 2, plus minus 3, plus minus 4, and 5. Well, it can be minus 5 too, but it's just same. And I'm just calculating them simultaneously because I'm just going to take square. So 1 and minus 1 is just going to give me the same thing. So if I just square these values, it will be 0, 1, 4, this is 9, so this is 16, so it's 6, 25 is going to be 5. And so these are going to be my values. And so this is obviously same for z squared too. So let's just multiply this by 3, and I will just get 3z squared. So it's going to be 0, 3, 12, so it's 2, 27 is going to be 7, this is 18, 8, and 15, 5. So I have that x squared has to be just congruent to 3z squared. So the way I can achieve is that only values that are matching is when they are both 0 or when they are both 5. Okay, cool. So I can say that both x and z, well, I could just use this for z too. Both x and z, can be just congruent to 0 or 5 modulo 10. Well, now let's think if they're congruent to 0. Let's look at this one first. If they're congruent to 5 modulo 10, well, they're both multiples of 5 because at modulo 10 it just gives you the last digit, so they have to be multiples of 5. And if they're 0 modulo 10, they're just multiples of 10. So either they're multiples of 10 or they're multiples of 5. Well, here you can say that they're both has to be, or I can just use here equivalent again. They has to be 0 modulo 5. So therefore I can just say x is multiple of 5. So I can say it's 5x1 and z is just 5z1. Okay, cool. So this is the first thing I found. And now let's substitute this at my equation. And let's see what do we get. Well, if I just put them, x squared is going to be 25 x1 squared plus 10y squared plus, so this is equal to just 75 z1 squared. And now I can just divide all sides by 5. I can do that. It's going to be 5x1 squared plus 2y squared. And this is going to be 15 z1 squared. Well, now if I look, I have, well, no matter what the x1 and z1 is, this thing is multiple of 5. This thing is also multiple of 5. So therefore, this thing has to be multiple of 5. And since 2 is not multiple of 5, y has to be multiple of 5. So from this part, I can say that y is also multiple of 5. So y is equal to 5y1. Okay. So now if I just substitute this one in here too, I will just get 5x1 squared plus, so this is just going to be 2550 y1 squared equal to 15z1 squared. And now I can just divide all sides by 5 again. x1 squared plus 10 y1 squared equal to 3z1 squared. Okay, now this is a bit interesting, because if you look at this one and our question, they're exactly the same. Instead of x's, I have just x1, y1, z1. So if actually x, y, and z is a solution, then x1, y1, z1 is also a solution, which means that x1 is just x over 5, y over 5, z over 5 is also a solution. This pair is also a solution. Well, then I can just keep doing this for this one too, and I will just get that. So x over 25, y over 25, z over 25. I don't have much space here. This will also be a solution, and I can just keep doing this as much as I want till one of them is not an integer. Well, they don't have to be, just divide 5 each time. And since these are supposed to be an integer, at some step this thing will just fail. Okay, but we will know that if this was existed, it wouldn't ever fail. So since it's gonna be a fails at some point, then this cannot be true. So there are no solutions here. Okay, so we found a contradiction, and so this means that there are no such x, y, and z pair that satisfies this equation. And that's the end of it.